Hello, my kiddos. Today we are going to talk about carbon. You have a CRQ to write. It's CRQ number 4. If you can't get to it through your class plan, you can get to it through content. So if you go ahead and click on content right here, it should take you to Unit 2. You can click on 2.03, Carbon and Life. And then you'll see CRQ 4 right here, and then here is your CRQ. You can also click on it right here. But hopefully you already read the lesson introduction, Carbon and Life, and you already read through the Explore section. But I'm going to go ahead and kind of give you a heads up about our CRQ today. The CRQ that we're going to do is right here. I'll put a box around it. It says carbon is an essential element for life. How does its atomic structure allow it to form so many different molecules? So there's the actual question. How does its atomic structure allow it to form so many different molecules? Now, you can find the answer if you read through lesson 2.03, but basically the answer is that carbon atoms have 4 valence electrons that bond readily to other atoms to form organic compounds. So that's kind of the answer in a nutshell, but I want to show you how this works. How does carbon's atomic structure allow it to form so many different molecules? Remember, carbon is the backbone of organic compounds. We talked the other day on, I guess it was Monday, we talked about these things called organic compounds, right? And organic compounds must have carbon atoms in them. Well, the cool thing about carbon, right, it has 6 protons in the nucleus. Most carbon atoms have 6 neutrons in the nucleus. But because carbon has 6 protons, here I'll draw a circle around the nucleus, that also means that it has 6 electrons on the outside. So 1, 2, 3, 4, 5, 6 electrons flying around on the outside. But what's really important are these outermost electrons. Okay, this is what makes carbon so unique, right? It says right here that carbon has unique bonding abilities. So how does carbon's atomic structure, back to the question now, how does carbon's atomic structure allow it to form so many different compounds? It has 4 valence electrons. That is how its atomic structure allows it to form so many different molecules. If I draw the symbol C right here for carbon, and I only include, we call this an electron dot diagram, and I only include the 4 outermost electrons. Yes, it has 6, but it only has 4 on the outside. 2 of those 6 are way here on the inside, right? But carbon has 4 valence electrons, just 1, 2, 3, 4. I'm going to put a dot around carbon for every one of its valence electrons. That's an electron dot diagram is what we call that. So carbon has 4 valence electrons. Everywhere it has a valence electron, other atoms can come in here and bond. Okay, so that makes it able to form a chemical bond in 4 different places. 1, 2, 3, 4. Other carbon atoms can come in and bond. So you can form these long chains of carbon. Now remember, it's got places to bond on top too, right? You can bring in hydrogen atoms. You could bring in oxygen atoms. Okay, so carbon, because it has these 1, 2, 3, 4 valence electrons, it has 4 bonding positions that allow for other atoms to come in and bond with the carbon. Okay, so the answer to the question, how does carbon's atomic structure allow it to form so many different molecules is right here. Carbon has 4 valence electrons, but it needs 8 to be stable. With 4 available spaces for electrons in its outer shell, a carbon atom easily forms covalent bonds with common atoms like hydrogen and oxygen. This unique characteristic makes it extremely versatile, so it is often the base element or backbone in a chemical compound. Okay? Carbon is present in all molecules critical to living things. We talked about those organic compounds that are important for us: proteins, fats, carbohydrates, and nucleic acids. Because carbon, right, only has 4 valence electrons, which gives it its 4 available spaces for other atoms to come in and bond. I'll show you again. It's got 1, 2, 3, 4 valence electrons. Because it has those 4 valence electrons, other atoms can come in and bond at those spaces right there. And if we have other atoms come in and bond, you can form these really, really amazing structures. Okay, so carbon atoms bond together to form molecules with several shapes. You can see carbon, 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 and then all of those carbons have hydrogens attached to them. So this is a straight chain carbon. You can have carbon chains that branch. So we have this backbone of 3 carbons here with a carbon branching off. You can form ring structures with carbon. Carbon, 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 with H's coming off of all the carbon. So because you can form, because carbon can form straight chains, branched chains, and ring structures, it can form many, 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 many molecules. Many molecules with several shapes. Okay, so again, the CRQ is pretty straightforward. The question is, how does carbon's atomic structure allow it to form so many different molecules? Carbon has 4 valence electrons, which gives it 4 available spaces for other atoms like hydrogen and oxygen to come in and bond. Now, as a comparison, I want to show you something. If you are hydrogen, you only have 1 valence electron. So there's only 1 bonding dock there, if you will. If you are oxygen, you only have 2 available spaces for something to come in and bond. It actually has 6 valence electrons, but it only has 2 spaces for something to come in and bond. So it's not as versatile. It can only have 2 things come in and bond. Hydrogen can only have 1 other atom come in and bond. But carbon, because it has 4 valence electrons, has 4 spaces where other atoms can come in and bond.